Hello, today we'll go over some advanced retrieval methods for a RAG system, then we'll run RAGAS metrics for performance and also some Langsmith evaluation for cost and latency. But first we'll start explaining each of the retrieval methods in short. For the first one, naive retrieval, it's a basic implementation for RAG where we're retrieving information and generating responses without any advanced optimization. Best matching 25 or BM25 looks for query specific matching or word matching. Multi-query retrieval is based on the user query. The LLM generates additional queries or similar queries that retrieves documents for each of those queries. This is to add more context. For parent document retrieval, here's where bigger documents will be stored on a memory store, different from the vector store. And then we chunk it into smaller documents, which we'll call child chunks. And then when we query our retriever, we compare the child chunks with our query vector and then return the parent chunks for each of these child chunks. In short, this will be, we query for child chunks and we return bigger documents or parent chunks, which is more context. Then contextual compression, or also known as re-ranking, is we pretty much compress our retrieved context to only the most relevant ones after a re-ranking process. Then for ensemble retrieval, what we'll be doing is joining together multiple retrievers and then we give them a weight. This is to combine the power of multiple retrievals at the same time. And then semantic chunking. While this is not a retriever, it will be interesting to put it as part of this evaluation. So the semantic chunking divides text into meaningful, semantically complete chunks to ensure the information's integrity during the retrieval process. So that being said, we're going to jump into the code right now, and pretty much it's very repetitive. And then we're going to jump into the evaluation section. Okay. First, we're going to be loading all of the dependencies and the keys, in this case, OpenAI, Cohere, and LangChain for later. Then we load the data to set the RAG system. And then here we set the quadrant vector store. Here we'll start setting all the RAG. So the first process will follow for all of the other retrievers. So pretty much we convert the vector store to a retriever object. In this case, the naive retriever. We set the augmented part. We're gonna use the same augmented template for all, and then we set the generation model, which is going to be GPT 4.1 nano. Then we set the RAG chain using LCell, and then we invoke the questions for each of the retrieval methods. So this is going to be the same process. I'm going to scroll quickly through the code, and then we're going to jump into the evaluation portion. So actually, I want to go over some questions. So the first one is to give an example query where BM25 is better than embeddings, and pretty much whatever that includes a specific keywords will be making BM to perform better because that's what it does. It match or look for exact keywords for its retrieval method. Then we have another question right here to explain how generating multiple reformulations of a user query can improve or recall. This is for multi-query retrieval. So generating multiple reformulations of a user query improves the recall by using different word choices. This is what the LLM does. And this is, they will be matching different documents. So for example, asking what the judge said about a fintech project could be rewritten as what feedback did finance applications get, right? So this will help the retrieval method to get more documents. And then finally, this is about the repetitive questions, how semantic chunking behave when this happens, and how to adjust the algorithm. Pretty much multiple questions might confuse the algorithm in the long term. So a way to improve this is by combining multiple embedding models or using specific keyword matching embedding models like BM25. So let's now jump into evaluation part to compare the results against all of them. So here we see the results. Here we can see that for RAGAS and metrics, compression retriever was the winner. And for latency and cost, the pattern retriever was the winner. So in conclusion, if you need, based on my tests, if I need accuracy or correct answers, then I will use compression retriever since it gives the best results like perfect precision and highest correctness, even though it is slower. And if I need fast and cheap results, then I could use pattern retriever. It is fastest, it is cheapest, but the quality of the answers is much lower. So in conclusion, based on this test, I could tell that, but in reality, it all depends on what's the application of the mission of the application that we'll be building. I will need to continue testing. I will need to continue modifying my queries, improving them to finally decide at some point what I'll be mostly using. I'll encourage you to do the same, and thank you very much for paying attention to today's session.